everyone, my name is Filip Rakowski and I am a CTO and co-founder of Vue Storefront. And today I'm going to talk about everything you need to build a perfect frontend for composable commerce. Let's start. But before that, you may ask, what actually is Vue Storefront? And well, we do our best to make it a perfect frontend for composable commerce, so you don't have to build it on your own. And it's a ready-to-use frontend with all the integrations out of the box, components, infrastructure that is super fast, and it really was great with any composable stack. And before we actually jump into the details of creating a perfect frontend, let's align on one thing. What exactly is a headless frontend? And is headless the same thing as composable, or maybe they are just a completely different things? I hear people mixing those terms a lot. And honestly, I don't think it should be like this because they're completely different terms. So in simple words, headless means decoupled, and it has nothing to do with how many backend vendors you make use of, or if you orchestrate the data or not. In monolithic applications, everything is tied together and coupled together. So you basically have one application that is rendering the front end, that is getting the data and managing all the other stuff. In headless commerce, you just detach the backend from the front end, and they talk to themselves through an API. Many shops actually finish on that stage, and honestly, it's perfectly fine to do this. But in the enterprise world, you usually have much more sophisticated requirements, and the cost of any trade-off is just much higher. And this is when the simplest headless setup would not be the best option, may not be enough for you, and you need to choose multiple vendors offering different services instead of going all in with your e-commerce vendor or its ecosystem. So this is the essence of composable commerce, and all of those technologies, they're connected, usually indirectly with your frontend. The frontend itself is being built using modern web technologies like Vue.js, Angular, or React. And this frontend is so-called single-page application. The main difference between single-page applications and multi-page applications that we got used to is the way how users are navigating through the application. So in multi-page applications, when you navigate to a different page, you have to download the whole HTML document again. So it includes header, footer, and everything else. And in single-page applications, you are patching only the piece that has changed without reloading the whole page, which delivers much faster and more pleasing in-app navigation for your users. And that's actually the biggest benefit of single-page applications when it comes to user experience. The in-app navigation is much, much smoother. And beware, because you will not see this in the Lighthouse score. So how we can build a great frontend for a composable commerce? First, let's define the areas we need to focus on to deliver great experience to our users. So first of all, it just has to look great and delight the eyes. Then it has to be fast, so our users will not leave the shop while waiting for it to load. Then it has to be discoverable and rank high in Google. In the end, we have to take care of the content. It has to be easy to modify and ideally personalized. So let's start with the design part. All the modern frontends are mobile first, using responsive web design. What does it mean? It means that we have a single website that adapts to the different screen sizes instead of shipping separate storefronts for different devices like mobile phones, laptops, tablets. In fact, majority of users these days are experiencing our website through mobile devices. So the point is not only to be responsive, but again, mobile first, not desktop first, as we used to do. Another thing that has changed a lot in the recent years is the way how we build and create the designs. So in the old days, we're basically creating them in Photoshop page by page. Now in single-page applications, everything is a component like header, footer, product tile, filter, and you actually build your website from reusable components. The design space also adopted this concept as design systems. And because of that, both design and the application itself can speak a common language, which is great. Now let's look at the definitions of both terms. Design system is a combination of a style guide and components that strictly apply the style guide. This way, we can be sure that all components follow the same rules, even on a big scale. Another advantage is ease of making variations of your master design. So imagine how useful it could be when your company has multiple brands. You can create so-called master design system and master components that then other brands just adapt and slightly personalize. Developers are adapting the design system in one of the front-end frameworks by creating a library of reusable components that then are used through the project. This way, we keep our interface consistent across all pages and even brands, scalable, and easy to work with. And here on the slide, you can see an example of a design system in Figma from our own open source library, Storefront UI. And we see like very clear guidelines on typography, colors, as well as definition of one components with all its variations and state. Then developers, when they use this design, they use this document as a source of truth about the application components. So they look exactly as here and have exactly the same states as here. You can also see that those components are already adapting the principles that are listed on this page. So colors, typography, so everything is very consistent with itself. And this is a huge, huge advantage. And as someone with a designer background, I can tell you that it was not so easy back then, especially when it comes to the developers. So coming back to the topic, those components that we create are then used to create sections and even full pages. And sometimes people, designers, group components based on the granularity. So they start with the smallest granularity, then from the smallest components, they create a little bit bigger components. From those components, they create the whole sections. And from those sections, they are creating the full pages. And one of those methodologies is called atomic design. And we are actually using it in our open source project Storefront UI. So if you want to learn more about this idea, you can just try it out on GitHub. It's completely free. You can make use of this. You can try it out. Just type the address of the GitHub repository and check it out. A perfect front end does not only have to look great, but it also has to be fast. And it's really, really, really important factor these days, because not only users are experiencing our website and deciding if they want to leave or not, but also Googlebot. Googlebot is browsing our website, checking how well it performs. And this is also influencing the SEO ranking. So both speed index is influencing this, but also metrics called Core Web Vitals. So if we score well on them in the real world with the real users, Google will give us a significant boost when it comes to the rank. But only if we complete all of them. Each of them is giving like a small boost. But if we combine all of them, we can really expect a significant boost in the SEO ranking. So that's another reason why you actually should care a lot about the speed of your website. So there are essentially three aspects that sum up to overall performance of your website. First of all, there is a server-side code execution that results in HTML document. And then this document is created. And the time this document has to travel through network could also be a significant part of this whole journey. And finally, when it arrives to the browser, we have something called client-side execution. So the JavaScript codes right now runs on the client. And this is usually the biggest bottleneck, by the way. To be more precise, JavaScript is the biggest bottleneck. Sometimes also images, so make sure to optimize them, but they're usually very easy to optimize. When you enter the stage when you have too much JavaScript, I'm speaking from experience, it's super hard to optimize it. So it's best to think about this from the day one, establish something called performance budget, which is basically a measurable limitation on how much JavaScript you could have, or it could also be represented as some metric. So for example, we don't want to exceed 4 seconds until time to interactive. So always think about the performance budget. To be more precise, what we want to optimize are two things. One is the first load, and another one is the in-app navigation. And usually in-app navigation is super fast, especially in the single page applications. So we will focus on optimizing the first load. So actually, when user is navigating to your website for the first time, either by Google or they're typing the name in the browser, you want your website to be visible as soon as possible, so they don't get irritated. For example, they could make something called mental context switch, which happens after 1 second of waiting, and they could, start browsing the pictures of cats or whatever. So in single page applications, the page is generated in the browser through JavaScript. That's a huge difference, because the biggest downside of this approach is that your users, they need to wait until the end of client-side execution, so the last phase, to see the page. And this could sometimes take a lot of time, especially on low-end devices. So you should make sure that your users can use your shop as soon as possible. And to make that happen, you should use something called server-side rendering. What is server-side rendering? In a simple words, it is generating the HTML of your website not in a browser, but in the server. And in the server, you generate a ready-to-use HTML, send it to the browser. The browser is executing the JavaScript on this HTML and makes it interactive. So because of that, your users, they don't need to wait for client-side execution to finish to actually see something, because the full HTML document is already there, it's just not interactive. But it could also take some time to generate on the server, and until that happens, your users really sees a blank screen, nothing else. There's no progression in here. You just have to wait for the whole document. And this is why you should cache those responses, so the code doesn't need to run. The ready HTML is already cached, and when the user is requesting it, they're getting it immediately. So you should cache those responses and then distribute them through a CDN to make sure that it's not only cached, but it's also distributed as soon as possible. Because what CDN is doing is actually sending the document from the closest location to the user. And how far someone is from the server, it really makes a difference. It really makes a difference. And sometimes it could take a lot of time to actually travel from one part of the world to another. And this could also be a huge bottleneck for your users. So it's also very important to take care of this part. And the fact that we are sending ready HTML to the front end also means that our single page application becomes SEO friendly, because when we are not using server-side rendering and when we are generating the page on the client side, the issue that could happen is that Googlebot will enter the website. It will see empty HTML because the page was not yet created by the JavaScript, and it will index what it sees. So it will index nothing, a blank page. And to be sure that this is not happening, we should render our page on the server. But a small information, you should always render and cache it without any personalized information, because otherwise sometimes you could end up sending a very personalized information from one user to actually everyone else, and you really don't want to do this. So server-side rendering is basically eliminating two issues of single page application at the same time. It's not only faster, but it's also SEO friendly. But the website that user receives, as we said before, is just a plain static HTML. So if they click on something, probably nothing will happen. And JavaScript code, it still has to be executed before the page becomes interactive. This process is called hydration. So you're basically hydrating dehydrated application, and because of that, it's becoming interactive. The problem with hydration is that it's eager. So we execute a lot of code that is not yet needed. This is why you should embrace lazy hydration. So only the visible components, they will become interactive. And everything else, everything that user does not see, it won't. And this way your page will be interactive much sooner, because you will not spend time on actually executing the code that is not needed right now. You can execute it on scroll, for example. Another thing that could become a bottleneck, especially when we are talking about composable commerce, is data. And especially in the composable commerce world, it could have a very, very big impact on your page performance. It could be a really like a major factor. And essentially, your page could be as slow as your slowest API. And in addition, probably each of the integrations you want to have on your front end, it will require additional JavaScript code to fetch the data, so-called SDK. And this could also negatively impact your page performance, especially when you have a lot of them, and each of them have their own SDK. So to deal with that issue, it's best to have a layer between the front end and your APIs called API Gateway. And what API Gateway does is basically collects the data from multiple sources and abstracts it for the front end. So the front end, it only speaks to the API Gateway and usually gets all the data from a single request. So the front end is not aware of what services you have, how complex they are, how hard it is to get the data. It takes care of it all. And in composable commerce, API Gateway in most situations is a must if you care about proper decoupling and, of course, performance. Now, let's talk about the last, but definitely not least important aspect of a good headless frontend, which is the content. So most of the headless CMS systems provide visual building capabilities, and it's a huge difference from the old way of doing things. Also, what we mean by headless CMS, the same thing as we mean with headless anything else. So what we're getting from the CMS is basically a JSON file that is a representation of our content. The frontend takes this JSON file and then interprets. Sometimes it has some components in it that has to map with the current frontend. Sometimes it has some personalization, etc. But basically what we're getting from a CMS is just a JSON that we are downloading from an API. And they are using these visual editing capabilities, and it's a huge, huge difference from the old way of doing things, and I will tell you why. Let's see how this process looked like before, and then look how it's looked like now with a headless CMS. So before, for both the initial release of the shop and then some iterations, so when you wanted to make some changes, you always needed multiple teams, developers, designers, marketers to be involved, and the process is rather long. So every new version of the website, it was actually a separate launch with a very complicated process. And because of that, it was very hard to actually react quickly to any changes in the market or to do a real-world marketing on your website. With a headless CMS, the flow is a little bit different because the designers, they are basically preparing the building blocks for the developers. The designers and developers, they're preparing the building blocks for the marketers. And the marketers are using those blocks to build the website using a visual builder. So they only need help of the developers to do the initial release of the website when they're preparing the documents for them. And after that, they basically do everything in the admin panel. And when they want to make any changes, they are just drag and dropping different components, changing content in the panel, clicking publish, and the new version is already there. It's much simpler, it's much cheaper. And this way you can make changes much, much faster. And you don't really need to even talk to the developers, which also makes it much cheaper. And usually the main content of every modern composable website is built inside a headless CMS visual editor. And on top of that, you can very easily also add personalization and then prepare this different version of your content for different users. So when you identify someone as a man, you can specify something different. When you identify someone as a developer, you can also show something different. All of that is being done inside the CMS or some third-party tool, like Uniform, for example. Sounds like a real breakthrough? To me as well. So, to summarize, to build a perfect frontend, you first need a mobile-first design, implementing a design system. Then, you need to make your website fast, because even the best design will not keep your users on it if it loads slow. And you have to do this by optimizing server-side execution, network transfer, and client-side execution. Thanks to server-side rendering, even though we are using JavaScript frameworks, our website is fast and crawlable. Then you need to integrate with a headless CMS to allow your marketing team to make changes to your shop using Visual Editor without help of developers. On top of that, we are making great mobile-first design, implementing a design system. And of course, each of those topics can be really like a separate presentation, but I think knowing those foundations will definitely help you to navigate in this complicated world. And I know that it could be super intimidating. Thank you.
Hey, thank you so much for watching that. I really hope you got value from it. By the way, if you want more where that came from, go to composability.dev and register to be a part of our community today. And if you want to be even more part of our community, go to Twitter and look up JavaScript Jam and follow us. Every Wednesday, we go live at 12 p.m. Pacific Standard Time, and we talk about anything and everything web dev. It's an open mic for everybody, whether you're a beginner, whether you've been doing this forever. We love to hear from everybody, and there's always so much value and good conversation going on there. We wanted you to be a part of it too, so come join us. And by the way, if you left a comment below, that's exactly where the comments are going to be answered during the live Q&As with the speakers. JavaScript Jam live on Twitter Spaces. All right, go to JavaScript Jam. Do it now. Follow us. All right, see you soon.